Good morning. In last lecture, we have started unit number 7. First, we will take revision within 5 minutes and then we will continue unit number 7. Okay. So, already we have started unit 7. So, unit 7 is related to shear stresses in beams, and we have discussed how to find out shear stresses. So by using equation tau, which is equal to SA y bar divided by IB. So by using this equation, we have to calculate shear stresses in that beam. Okay. After that, we have discussed what is the relation between maximum shear stress and tau average for rectangular as well as circular section. So tau max, which is equal to 3/2 tau average for rectangular section, and tau max, which is equal to 4/3 tau average for circular section. After that, we have solved one numerical on that symmetric section. Okay, so we will continue. Please write down next example. Next example. A simply supported beam of simply supported beam of simply supported beam of 10-meter long 10-meter long 10-meter long is subjected to is subjected to 100 kilonewton per meter 100 kilonewton per meter 100 kilonewton per meter UDL. Stop. Find the shear stresses. Find the shear stresses. Find the shear stresses at important locations at important locations and draw shear stress distribution diagram shear stress distribution diagram draw shear stress distribution diagram. Okay, so this is the question. First, I will draw here given I section, then we will solve problem. Okay, so this is symmetric I section is given. and simply supported beam is given. Okay, simply supported beam with uniformly distributed load on that beam. So this is the simply supported beam AB, and on that beam uniformly distributed load is applied, and intensity of uniformly distributed load is 100 kilonewton per meter. 100 kilonewton per meter. Okay, so shear force is nothing but at this A point, how much shear stress will be there? WL by 2. And here also WL by 2. So WL by 2, which is equal to how much? 100 into 10. That is 1000 divided by 2. 1000 divided by 2. And here also 1000 divided by 2. So this is 500 and this is also 500. Okay, 500 kilonewton. Then we will draw shear force diagram for this. So shear force diagram, all values are positive. At A point, upward force is there and intensity is 500. After that, next at B point, okay, after that in between A to B, this uniformly distributed load is applied. Okay, and before this B point, load shear force is 500. So we will mark point here 500. Okay, and here this is at B point, shear force is 0. So we will connect by inclined line. किती वाजलेत? रोजच का लेट होतोय तुम्हाला? Here 500, here also 500. Now we will start solving. Okay. So first step is we have to find out moment of inertia. Okay, so this section is symmetric section. So due to this symmetry, we are able to mark y bar directly. Okay, so first we will mark y bar. So it will act at centroid of this. Okay, so distance from bottom and top is same. So how much you calculate and tell me this distance is how much and this distance is how much. 300 plus 20 plus 20. 340, na? So 340 by 2. 170. 170. And this is also 170. Okay. So first we will calculate Ixx. So moment of inertia about x axis, which is equal to. First we will consider this is a whole rectangle, and after that we will subtract this portion and this portion. So capital BD cube divided by 12 minus 2 into small BD cube divided by 12. So Ixx, which is equal to capital B is 200 into capital depth 340. So 340 cube divided by 12 minus 2 into small b is, okay, we will calculate here. This is 200. Out of that, this 20 we have to subtract. So 200 minus 20 is 180. 180. Okay, so 180 divided by 2, that is 90 into depth. So this depth is given 300 cube divided by 12. So you calculate and tell me Ixx, which is equal to how much? Yes, Ixx, which is equal to how much? 250.06 into 10 raised to 6 raised to 4. Okay, raised to 4. After that, we will calculate shear stresses at various locations. So first we will mark here points and then we will calculate. Suppose this is A point, this is B, this is C, suppose this is D, this is E point, F point, and G point. So already we have studied that shear force at top and shear force at bottom is 0. So tau A, which is equal to tau G, which is equal to 0. After that, we will calculate at tau B. So tau B is nothing but SA Y bar divided by IB. So tau B, which is equal to shear force is 500. So 500 into 10 raised to 3 into area. So area is 200 by 20. So 200 into 20 into y bar. Okay. So from this neutral axis to centroid of this. So 170 minus 20 by 2. That is 160 divided by 2. So this is the SAY bar. Now IB. I already we have calculated 250.06 into 10 raised to 6 into B. We are calculating at this B point. So width is nothing but 200. Huh? The application. Okay, so this is the width. So calculate and tell me the value of shear stress at B point, tau B, which is equal to 6.39 Newton per mm square. So this is the shear stress at B point. After that, we will calculate shear stress at this C point. So next point is tau C. So tau C, which is equal to SA y bar divided by IB. Okay, so tau C, which is equal to shear force is 500 into 10 raised to 3 into, so width is here 200 into depth is also 20. So 200 into 20 into, now we have to find out stress at C point. So whenever we will calculate at that particular point, so you have to consider area above this point and CG for this particular section. Okay, so here same centroid will be there. Okay, 170 minus 20 by 2. Only here width will be changed. Okay, so 250.06 into 10 raised to 6 into, now you observe here at C point width is 20. So tau C, which is equal to how much? बघ आता इथे एक तुम्हाला स्मॉल थोडीशी ट्रिक सांगते की हे सगळं कॅल्क्युलेशन करत बसायचं नाही. हे तुमच्याकडे आन्सर काय आहे 6.39. हा, त्याला आपण 200 ने डिवाइड केलेलं आहे, तर त्याला 200 ने मल्टिप्लाय करायचं आणि डिवाइडेड बाय 20 करा, आन्सर आहे त्याचा 63.98. आणि एकाने कोणी जर क्रॉस व्हेरीफाय करा इक्वेशननी पण तेच आन्सर आहे त्याचा, तेच आन्सर येणार. ते डबल करत बसण्यापेक्षा लक्षात ठेवायचं 200 नी डिवाइड केलेलं आहे, 200 नी मल्टिप्लाय करायचं आणि जेवढी विड्थ आहे त्या विड्थनी डिवाइड करायचं, तुम्हाला आन्सर मिळतं. येते का? Then we will calculate shear stress at D. So shear stress at D is nothing but shear stress at neutral axis. So tau D, which is equal to SA y bar divided by IB. So where we are calculating at D. So here two strips will be there, this and this one. So we have to take area for this both strips. So tau D, which is equal to shear force is 500 into 10 raised to 3. Now we have to consider two areas. So first we will take this 200 strip. So 200 into 20 into centroid is same 170 minus 20 by 2. So 170 minus 20 by 2. So this is for this first strip. Now we will focus on this second strip. So plus, now this is 20 and this distance 150. Okay, so 20 into 150 into centroid of this 150. So 150 by 2. 150 by 2. Now say y bar over, we will divide by I 250.06 into 10 raised to 6 into width. Now at D width is 20. So you calculate and tell me tau D, which is equal to how much? नाही, आता इथे तुमचं हे ऍड झालंय ना, ऍड झालेलं आहे त्यामुळे इथे नाही, फक्त तुम्ही ह्या कॅल्क्युलेशनला करू शकता इथे. Yes, tau d, which is equal to how much? No, 63.98 is here. So in that we are adding this 20 into 150 into 150 by 2. So answer must be greater than the 63.98. Yes, those students are attending online. Please calculate value and tell me tau d, which is equal to how much? 86.47. Okay, please check here. Any other students got same answer or not? 86.47 Newton per mm square. Okay, so this is the shear stress at neutral axis or shear stress at D. Okay, due to this symmetric section, wherever shear stress, okay, what is the amount of shear stress at B, which is equal to shear stress at F, and shear stress at C, which is equal to shear stress at E. Due to this symmetric section, if unsymmetric section, at that time we have to calculate for all points. Okay, so now shear stress calculation is over. We will draw shear stress distribution diagram. So first I will draw here given figure. Okay, so suppose this is baseline. First we will mark points here and then we will draw figure. So this is our A point, this is B, C, this is D, E, F and G. So shear force, sorry, shear stress at A and G is 0. After that, shear stress at B. At B is 6.93. So suppose here 6.93. After that, shear stress at C 63. So same line shear force will be there 63.98. Shear stress at D is 86. So we will mark here 86.47. After that, shear stress at E point is 63.98. That means same value is here 63.98, and then shear stress at F, which is equal to 6.93. So we will locate here 6.93. So from this, look at this 6.39. 6.39. So from this A to B parabolic, B to C straight line, from C to D and D to E parabolic, then E to F straight line, and then F to G parabolic. So this is the stress distribution diagram. Okay, please take screenshot. So we will solve next example. Okay, so we will solve next example. Please write down. A beam of span 3 meter. A beam of span 3 meter. A beam of span 3 meter. Beam of span 3 meter carries a central point load. Carries a central point load. Carries a central point load. Full stop. The beam section has overall depth. The beam section has overall depth. Has overall depth. Beam section has overall depth 300 mm. 300 mm and width of 200 mm and width of 200 mm. 200 mm. Full stop. If the maximum shear stress is to be, if the maximum shear stress is to be, shear stress is to be 50 Newton per mm square. 50 Newton per mm square. Full stop. Calculate the value of centrally applied point load. Calculate the value of centrally applied point load. Centrally applied point load. Full stop. So first we will draw the cross section of beam. So here rectangular beam is given, having width is 200 mm and depth is nothing but 300 mm. Depth is nothing but 300 mm. Okay. After that, simply supported beam is given. Simply supported beam is given, and on that beam central point load applied W. We have to find out this W. So if central point load is applied at that time, shear force is W by 2 here and W by 2 here. Okay. So first we will write one equation. You know that maximum shear stress, which is equal to 3 by 2 tau average. Here maximum shear stress is given. Okay. Central point load, overall section 300. If the maximum shear stress is 50 Newton per mm square. So tau max value is given 50, which is equal to 3 by 2 into tau average is nothing but shear force divided by cross section area of that particular beam. So 50, which is equal to 3 by 2 into S divided by width is 200 into depth is 300. So 50 into 2 into 200 into 300 divided by 3, which is equal to S. So accordingly, you calculate the value of S and tell me S, which is equal to how much. So S, which is equal to 2 into, okay, 2 into 10 raised to 6 Newton. And suppose I want this value in kilonewton, then S, which is equal to 2000 kilonewton. Okay, 2000 kilonewton. So this is the shear force. But in this question, shear force is asked? No. What asked? We have to find out the value of W. So shear force is nothing but W by 2. Shear force, reaction at A. So shear force is W by 2. So shear force is 2000, which is equal to W divided by 4. So W, which is equal to 4000 kilonewton. So likewise, examples will be asked on this rectangular section. Okay. So please take screenshots. Then we will solve same example, but in that shear stress as well as bending stress is given in next example. Okay, please take screenshots fast. If you have taken screenshots, shall I take next example? Yes, those students are also in classroom. Whenever I am asking take screenshots, at that time you take. But whenever I am not allowing mobile phones, at that time you not use. Okay. So next, we will take next example. Write down. A simply supported wooden beam. A simply supported simply supported simply supported wooden beam simply supported wooden beam of span 1.3 meter of span 1.3 meter having a cross section having cross section 150 mm by 250 mm 150 mm 150 mm width and 150 mm width and 250 mm depth and 250 mm depth 250 mm depth carries a point load at the center carries a point load carries a point load at the center carries a point load at the center full stop. The permissible stresses are the permissible the permissible stresses are 7 Newton per mm square in bending 7 Newton per mm square bending in bending and 1 Newton per mm square in shearing in shearing full stop. Calculate safe load W calculate safe load W. So here we have to apply two equations. So we have to calculate load by bending equation as well as load by shear stress equation. So first we will draw rectangular section is given. So I will draw figure here for this rectangular section. So for this rectangular section, width which is equal to how much and depth is So width is 150 and depth is 250. Okay. Then simply supported beam is given, and on that beam, which type of load is applied? Central point load is applied, and we have to find out this W. So shear force is nothing but W by 2, and here also W by 2. Okay, suppose this is L. So first we will apply bending equation. Bending equation. So bending stress sigma, which is equal to M by Z, M by I into Y, nothing but M by Z. So section modulus for this rectangular section is BD square by 6. So bending stress is given. We will put value here. Bending stress is 7, which is equal to M divided by Z is BD square by 6. So 7, which is equal to M divided by BD square by 6. So B is 150. B is 150 into D is 250 divided by 6. So M, which is equal to, you calculate and tell me M, which is equal to how much? Yes, 250. Here 250 square. So M, which is equal to 7 into 150 into 250 square, then divided by 6. So M, which is equal to 8.93 into 10 raised to 6 Newton mm. But I want this moment in kilonewton meter. So how I will convert? 10.93 kilonewton meter. Okay. So that's 10 raised to 3 for Newton and 10 raised to 3 for mm. So Newton to kilonewton 3 cancel and mm to meter 3 cancel. So 10.93 kilonewton meter. Okay, from this M, we will calculate this W. Suppose this is simply supported beam. Having span is given and the span for this simply supported beam is 1.3 meter. Okay, this is 1.3 meter. So if simply supported beam is given and on that beam central point load is applied, so M, which is equal to WL divided by 4. This is the bending moment formula for this simply supported beam. So moment already we have calculated 10.93, which is equal to W into 1.3 divided by 4. So 10.93 into 4 divided by 1.3, which is equal to W. So W, which is equal to how much? 33.63 kilonewton. So that much stress will, load by bending equation. Now we will calculate by shear stress equation. Okay, we will calculate by shear stress equation. So shear stress equation, tau max, which is equal to tau max, which is equal to 3 by 2 tau average. 3 by 2 tau average. Maximum stress is given 1, which is equal to 3 by 2 into tau average is S divided by BD. Okay, so 1, which is equal to 3 by 2 into S divided by B is 150 into D is 250. So 1 into 150 into 250 into 2 divided by 3, which is equal to S. So S, which is equal to 25 into 10 raised to 3 Newton, and in kilonewton 25 kilonewton. Okay, so this is the shear force. But whenever you have to calculate W, so shear force is W by 2. So shear force is 25, which is equal to W by 2. So W, which is equal to 25 into 2, therefore W, which is equal to 50 kilonewton. So whenever we will apply bending equation, at that time force which is equal to 33.63 kilonewton, and whenever we will apply shear stress equation, so W which is equal to 15 kilonewton. Okay, please take screenshots. Okay, next, in next example you have to find out W as well as L. You have to find out W as well as L. Same question is given. So if your screenshot is over, shall I take next example? Okay, so please write down. I will read, you write down please. Find the length and find the length and find the length and point load. Find the length and point load applied at applied at applied at applied at the center of simply supported beam. Applied at the center of simply supported beam. Full stop. The width of beam is 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 width of beam is 150 mm 150 mm and depth is 250 mm and depth is 250 mm. Depth is 250 mm. Full stop. If permissible stresses are if permissible stresses are 7 Newton per mm square 7 Newton per mm square in bending and 1 Newton per mm square in shearing. 1 Newton per mm square in shearing. Okay, so this is the inverse type of problem. So here simply supported beam is given. On that beam central point load is applied. So due to this, first you have to find out the load and second is nothing but span for this beam. So suppose this is simply supported beam and on that beam central point load W is applied. So at that time reaction at A which is equal to W by 2 and reaction at B which is equal to W by 2. So according to this shear force diagram is W by 2 going upward at A point. In between A to C, there is no force, so diagram is constant. After that, at C point, W force is downward. So up to this baseline W by 2. And we have to go below baseline W by 2. After that, in between C to B, there is no force. And at B, upward W by 2. So this is our shear force diagram. This is shear force diagram. So here W by 2 and here W by 2. And then you have to draw bending moment diagram for this. So bending moment diagram is bending moment at under point load value will be there. So bending moment for simply supported beam if central point load is applied WL by 4. Okay. Now, first we will calculate W. So, two stresses are given. So, first, suppose we are going to use first bending stress, then sigma which is equal to m by z. Here you will get moment value. Okay. From then moment which is equal to WL by 4. So here two unknowns are there. W is unknown and L is unknown. So this equation first not applicable. And suppose we are using max shear stress equation, then 3 by 2 tau average. Tau average means S divided by B into D. So here shear force you will got. From this you will calculate W, and after that we will apply this bending equation and we will find out this L. Okay, so this is inverse type of problem. So first we will apply shear stress equation. So shear stress tau max which is equal to 3 by 2 tau average. Okay. So tau max is 1 given 3 by 2 into tau average is S divided by BD. That is, first I will write here so your confusion will not be there. So 1 which is equal to 3 by 2 into S divided by 150 into 250. So S which is equal to 2 into 1 into 150 into 250 divided by 3. Already you have calculated S which is equal to how much? 25,000 Newton, and S which is equal to 25 kilonewton. From this we will calculate W. So W which is equal to, first we will write in terms of shear force. So shear force is W by 2. S which is equal to W by 2. Shear force is 25 which is equal to W by 2. So W which is equal to 50 kilonewton. Now only one unknown is remaining. That is L is remaining. So for this we will apply bending stress equation. So what is our bending stress equation? Sigma which is equal to m by z. So sigma is given. Z we have to calculate for this rectangular section. And from this you will get this moment. So sigma is 7 which is equal to m by z. Z is BD square divided by 6. So 7 which is equal to this 6 will go numerator. So 6m divided by B is 150 into D is 250 square. So M which is equal to 7 into 150 into 250 square divided by 6. And M also already you have calculated M which is equal to 10.93 into 10 raised to 6 Newton. And if you want in kilonewton meter, 10.93 kilonewton meter. Okay, here Newton mm. Then we will apply bending moment formula. So M which is equal to WL by 4. So M is 10.93 which is equal to W 50 into L divided by 4. So L which is equal to 10.93 into 4 divided by 50. So L which is equal to 0.87 meter. So first you have to understand which type of question is given, and first we have to apply which equation. Once you get idea which equation you have to apply, from that equation which parameter you will get, then and then only you are able to solve these questions. Okay, please take screenshots. So we will solve numerical on unsymmetric section. Because of till now we have solved numericals on symmetric sections. So we will solve on unsymmetric section. Okay, so we will solve example on unsymmetric section. Please write down next example. A cast iron bracket, a cast iron bracket a cast iron bracket has a cross section of I shape as shown in figure. Full stop. The section is subjected to a shear force of the section is subjected to a shear force of 1600 kilonewton, that is 1600 kilonewton. Full stop. Draw the shear stress distribution over the section. Draw the shear stress distribution shear stress distribution over the section. Okay. I will draw figure here. You can also draw. Now here unsymmetric section is given. Okay, this is 300, this is 50, this is also 50, this dimension is 200, this is 50, and this depth is 300. Okay, so this is the unsymmetric I section. So for this, first we have to prepare table for finding out Ixx. So what is our table? First we have to take section. We will mark table first, then we will solve. So first section, after that area of that particular section, after that no yi is there, after that ai yi, after ai yi square, and last one is the I cell. So first we will prepare this table and then we will solve this example. So first parameter in that is section here. After that area for that particular section, y bar for particular section, ai yi, then ai yi square, and last one is the I cell. Okay, so first we will divide into three parts, first, two, and three. Okay, so first we will dealing with this first section. So section is first. For this area is 200 into 50. So 200 into 50, which is equal to 10,000. After that yi, we are calculating from this base, 1 axis. We will call as 1 axis. So 50 by 2, nothing but 25. So ai yi 25 or 250 into 10 raised to 3, no? Yes, 250 into 10 raised to 3. After that ai yi square, that is 25 square into ai. So 625 into 10 raised to 4, or yes, 625 into 10 raised to 4. Now this is the rectangular section, and for rectangular section moment of inertia is Vd cube by 12. So width is 200 into depth is 50. So 200 into 50 cube divided by 12. So moment of inertia for that section 1, which is equal to how much? 2.08 into 10 raised to 6. Now section 1 is over. We will go towards section 2nd. So section 2nd is this. So for this section 2nd, area is, this is 50 and this is 300. So 50 into 300, which is equal to 15,000. Na? Okay, after that yi. 50 plus 300 by 2. So here 50 plus 300 by 2, which is equal to 200. After that ai yi. 3 into 10 raised to 6. After that ai yi square. Okay, 600 into 10 raised to 6. After that, again this is rectangular section. So BD cube divided by 12. So width is 50 into depth is 300 cube divided by 12. So which is equal to 112.5 into 10 raised to 6. Now section 2 is over. We will move towards section 3. So this is our section 3. So for section 3, this is width and this is depth. So 300 into 50, area is same, 15,000. After that, you have to calculate yi from this base. So 50 plus 300 plus 50 by 2, that is 350 plus 50 by 2. So 375. Then AIYI 5.6 into 10 raised to 6. After that AIYI square 2.1 into 10 raised to 9. 2.10 पुढचे डिजिट सांगा काय आहेत? 109 into 10 raised to 6. After that, I self is BD cube upon 12. So width is 300 into 50 cube divided by 12 is nothing but how much? Okay, 3.12 into 10 raised to 6. Now sections are over. We will take addition of all these. So first we will take summation of area. So summation of area, which is equal to how much? 15 plus 15, 30, that is 40,000, right? After that, this is not required. Summation of AIYI. Okay, here also you take 5.625 is there. Okay, so 8 point something will be comes. How much? Yes, 8.875 into 10 raised to 6. Then summation of AI yi square. Okay, 2.10 into 10 raised to 9. Huh. Last next. Some answer. Summation AI yi square. Two point seven one five we will write into 10 raised to 9, and summation of I self which is equal to 117.7 into 10 raised to 6. So first we will calculate y bar. So y bar is summation of ai yi divided by summation of ai. So y bar which is equal to summation of ai yi is 8.875 into 10 raised to 6 divided by 40,000. So from this you will get y bar. So y bar which is equal to 221.875 mm. Okay, we will locate from bottom 221. So suppose here this distance is 221.875. So you calculate this top distance and tell me value of this. 178.125 or 35. 125. Okay. After that, we will calculate moment of inertia about 1 axis. So I11, which is equal to summation of I self plus summation of AI yi square. So I11 which is equal to summation of I self, that is 117.70 into 10 raised to 6 plus summation of ai yi square is 2.715 into 10 raised to 9. So you calculate I11 which is equal to how much? Okay, 2.83 into 10 raised to 9 mm raised to 4. After that, we will calculate Ixx. So I11 which is equal to Ixx plus summation of AI into y bar square. So I11 is 2.83 into 10 raised to 9 which is equal to Ixx plus 40,000 into y bar is 2 to 1. 221.875 square. So you calculate and tell me I11 which is equal to how much? Sorry, Ixx which is equal to 2 point. चुकते कहते चेक कर 2.8 तर ऑलरेडीच इकडे आहे ना आपला I11 त्याच्यातून आपल्याला 40,000 इंटू 221.875 चं स्क्वेअर मायनस करायचं किती येतं Yes, Ixx which is equal to 863.07, but here I have got 80 into 10 raised to 6 mm raised to 4. So this is the moment of inertia. Once you got moment of inertia, now you are able to calculate stresses. So first we will mark point here. This is A point, this is B point, this is C, this is D point, this is E point, F and G. Now you tell me shear stress at C which is equal to shear stress at E. No, because of this is unsymmetric section. So we have to find out shear stress for each and every point here. So first we will write shear stress at A which is equal to shear stress at G which is equal to 0, because of already we have studied it at top and bottom shear stress is 0. After that we will calculate shear stress at B. So tau B which is equal to SA y bar divided by IB. So which is equal to, we will write below. S is shear force is given 1600 into 10 raised to 3 into area. Okay, we are calculating at B. That means above this B point we will consider area. So 300 multiplied by 50. So 300 by 50. Now you have to focus on this CG. So CG means from this to this distance. So how you will get? From this neutral axis to top distance is 178.125 minus 50 by 2. So this is the centroid. And after that divide by. Moment of inertia is 863.80 into 10 raised to 6 into here width is 300. So you calculate and tell me tau B which is equal to how much? One 4.18. Okay. 14.18 Newton per mm square. After that, we will calculate shear stress at C point. So at C point, this width will be changed only. So instead of 300, at C point width is 50. So tau C which is equal to tau C which is equal to SA y bar divided by IB which is equal to 1600 into 10 raised to 3 into 300 into 50 into 178.125 minus 50 by 2, same as it is. Only width will be changed here and the value of width is, instead of this 300 width is 50. बघा हे कॅल्क्युलेशन रिपीट करत बसायचं नाही. 14.18 इंटू 300 आपण इथं 300 ने डिवाइड केलं होतं त्यामुळे मल्टिप्लाय करायचं आणि फक्त 50 ने डिवाइड करायचं तर तुम्हाला आन्सर मिळेल. सो टाउ सी विच इज इक्वल टू ओके 85.02 न्यूटन पर mm square. Okay, 0.8 Newton per mm square. After that, we will calculate at D point. So tau D which is equal to tau D. Now we are calculating at this D point. Okay. So we have to consider this area as well as this area. So tau d, which is equal to SA y bar divided by IB. So 1600 into 10 raised to 3 into, here two strips will be there. First one is the 300 into 50 into 178.125 minus 50 by 2 plus, now for this second, width is 50 but depth is how much? 50 into, कशी 150 असेल? सेक्शन आता सिमेट्रिक आहे का? सेक्शन सिमेट्रिक आहे का आता? नाहीये. बघा आता ह्या डेप्थ, या पॉइंट पासून टॉप पर्यंत डिस्टन्स किती आहे तुमचं? 178. जर त्या 178 मधून हे 50 मायनस केले तर आपल्याला ही डेप्थ मिळेल. तर ही डेप्थ किती असणार आहे मग तुमची? 178.125 मायनस 50, दॅट इज 128.125 and into centroid is 128.125 divided by 2, then divided by moment of inertia 863.80 into 10 raised to 6 into width is 50. So tau d, which is equal to, yes, tau d, which is equal to how much? Not possible at D stress is maximum. डबल ब्रॅकेट करायला विसरत असाल तुम्ही, ते डबल ब्रॅकेट करा देतात. येस, 100.29 न्यूटन पर mm स्क्वेअर. 100.29 न्यूटन पर mm स्क्वेअर. बघा तुम्ही ज्यावेळी प्रॉब्लेम सॉल्व्ह करणार आहे त्यावेळी लक्षात ठेवा की स्ट्रेस हा टॉपला 0 आहे, बॉटमला 0 आहे आणि जिथं कुठं तुमचा सेंट्रॉइड येणार आहे किंवा न्यूट्रल ऍक्सिस त्या पॉइंटला तुमचा मॅक्सिमम आला पाहिजे. त्या पॉइंटला जर व्हॅल्यू कमी येत असेल तर तुमचं कॅल्क्युलेशन चुकते. हे तुमचं क्रॉस व्हेरिफिकेशन असेल. आफ्टर दॅट वी विल कॅल्क्युलेट फर्स्ट ऍट एफ, देन वी विल कॅल्क्युलेट ई. आपण बघा एफ ला कॅल्क्युलेट केलं तर इथे ई ला फक्त विड्थ चेंज होते, त्यामुळे फर्स्ट वी विल कॅल्क्युलेट एफ ऍट एफ. So shear stress at F, nothing but tau F, which is equal to SA y bar by IB. So tau F, which is equal to shear force is 1600 into 10 raised to 6 into, now you concentrate here below F, we are calculating here at F. Okay, so below F area is this strip. So 200 into 50. So area is 200 into 50. Now we have to take centroidal distance. Okay, so from this neutral axis to base distance is 221.875. From that we will divide by this half distance. म्हणजे काय असणार आहे आपलं इथं पासून ते इथं पर्यंत डिस्टन्स आपल्याला घ्यायचं. तर ते कसं लिहिणार मग into 221.875 minus 50 by 2. Then divide by moment of inertia is 863.8 into 10 raised to 6 into, now you observe here width is 200, so into 200. So you calculate and tell me tau f, which is equal to how much. Yes, 1600 into 10 raised to 6 नाही आहे, इथे 10 raised to 3 आहे. किती येते आन्सर? Yes, stress at F is 18.23 Newton per mm square. Then next last point is remaining, that is shear stress at E point. बघा आता कुठल्या पॉइंटला फाइंड आउट करायचा राहिलेला आहे तुमचा E पॉइंटला. तर F पॉइंटला जे अदर व्हॅल्यू होतात त्या सेम राहतील, फक्त विड्थ 200 च्या ऐवजी किती येणार आहे तुमची 50 असणार आहे. सो shear stress at E, which is equal to 1600 into 10 raised to 3 into 200 into 50 into 221.875 minus 50 by 2, then divided by 863.8 into 10 raised to 6. Instead of this 200, width will be 50. So tau E, which is equal to, yes, 72.92 Newton per mm square. And then finally we will draw shear stress distribution diagram. At G already we have calculated, at G stress is 0. First I will draw original section here, then we will draw shear stress distribution diagram. So here unsymmetric section is given. Okay, first we will extend all lines. Okay, so this is our neutral axis, then this line, and last one this line. Okay, so we will mark here, we will write dimensions here. This is 300, this is 50, this is again 300, this is 200, this is 50. Here we have marked A point, here B, C, D, E, F, and last one is the G. So first we will draw baseline and then we will draw figure. So suppose this is our baseline of this shear stress distribution diagram. We will mark all points. Shear stress at A is 0 and shear stress at G is 0. After that, shear stress at B. So shear stress at B is 14.18. 14.18. So we will mark here 14.18. After that, shear stress at C 85.08. So shear stress at C, which is equal to how much? 85.08. So we will mark here 85.08. After that, shear stress at D, 100.29. So suppose here 100.29. After that, shear force at E, 72.98. So something above here 72.92, and shear stress at F is 18.23. That means 18.23. So connection from this A to B is parabolic. After that, straight line. Here straight line will be there. After that, from this C to D parabolic, from this D to E also parabolic. After that, here straight line, and here also parabolic. So this is the stress distribution diagram. Okay, please write down. How much time is remaining? 30 minutes, na? Okay, take screenshots. So we will take example, next example. Within 30 minutes, we will solve next example. Please take screenshots. Okay, please write down next example. Same I section, unsymmetric I section is given. Okay, only dimensions will be changed. A cast iron of I section, a cast iron of I section, a cast iron of I section, cast iron of I section, as shown in figure, as shown in figure, as shown in figure, is subjected to a shear force, is subjected to a shear force, subjected to a shear force of 800 kilonewton, shear force of 800 kilonewton. Full stop. Draw shear stress distribution diagram. Draw shear stress distribution diagram. Shear stress distribution diagram. Draw shear stress distribution diagram. Okay, I will draw figure here first. So here also unsymmetric section is given. So this is the 250. This is 50. His height is 250. This is 50. This is also 50. And this is 150. Okay. So same procedure we have to follow here. First we have to find out Ixx. So for that first we will prepare table here. So in that first is section. After that area. After that y bar for that particular section. After that ai yi. Then next ai yi square. And last one is the I cell. Okay. So first we will write here section, then AI, then AI square, and last one is the I cell. So first we will consider this section 1, this is 2 and 3. So for section 1, area is 150 by 50. So 150 into 50, which is equal to how much? 7500. Okay, 7500. So yi, we will consider this as a 1 axis. So from this 1 axis, y bar is 50 by 2, which is equal to 25. After that ai yi, 7500 into 25. 18750. ai yi square 93750. 25 square is 625 into 7500. After that I self is PD cube upon 12. So 150 into 50 cube divided by 12, which is equal to how much? 1.56 into 10 raised to 6. So here section 1 is over. Then we will calculate for section 2. Okay. So for section 2, area is, this is 50 and this is 250. So 50 by 250, which is equal to 12500, right? 12500 yi 50 plus 250 by 2. So 50 plus 250 by 2. How much? 4.10 raised to, okay. Then ai yi here yi, which is equal to how much? 250 by 2 is 125 plus 50 is 175. Then ai yi 175 into 12500. 2.18 into 10 raised to 6. ai yi square 382.8 into 10 raised to 6. I self, that is BD cube upon 12. So 50 into 250 cube divided by 12, which is equal to 65.1 into 10 raised to 6. After that, we will move towards third section. So for third section, area is 250 by 50, which is equal to same 12500. Yi. This 50 plus 250, that is 300 plus 50 by 2. So 300 plus 50 by 2. So 325. After that, Ai, Yi, which is equal to 4.06 into 10 raised to 6. Ai square 1.32 into 10 raised to 9. And I self is BD cube upon 12. So 250 into 50 cube divided by 12, which is equal to 2.6 into 10 raised to 6. Now we will take addition. So summation of AI. 32500. This is not required. Then AI. Yes, how much? 6.5. 6.4 into, okay, then AI square. That answers are not available with me. So you do calculations properly and tell me. AI square. One 1.707 into 10 raised to 9, and then summation of I self 69.10 raised to 6. After that, we will calculate y bar. So y bar is summation of ai yi divided by summation of ai. So y bar, which is equal to summation of ai yi is 6.4 into 10 raised to 6 divided by summation of ai 32500. So y bar, which is equal to 1.9. चेक करा बरं तेवढाच येते का आन्सर 196.9. So suppose here we will mark from this bottom, this distance is 196.9. So you calculate this top distance and tell me how much. 153.1. Okay. Then we will calculate moment of inertia about 1 axis. So I11, which is equal to I11 summation of I self plus summation of ai yi square. So I11 which is equal to summation of I self 69.26 into 10 raised to 6 plus summation of AI square 1.707 into 10 raised to 9. So I11 which is equal to 1.77 into 10 raised to 9 raised to 4. After that, we will calculate Ixx. So I11 which is equal to Ixx plus summation of AI into y bar square. So 1.77 into 10 raised to 9 which is equal to Ixx plus 32500 into 196.9 square. So you calculate and tell me Ixx which is equal to. How much? 5 6 point into चेक करा बरं एवढं येत नसेल आन्सर. फाईव्ह बरोबर आहे पण 1.6 इतकं येत नाही असं मला वाटतंय. Okay, then next is we have to calculate stresses. So suppose this is A point, this is B, C, D, E, F and G. So tau A which is equal to tau G which is equal to 0. After that we will calculate at B. So tau B which is equal to SA y bar divided by IB. So which is equal to shear stress is how much given 800. 800 into 10 raised to 3 into area. So above this B point, this strip will become 250 into 50 into y bar is 153.1. 153.1 minus 153.1 minus 50 by 2. Then divided by Ixx is 516.2 into 10 raised to 6 into width is 250. So tau B which is equal to just calculate fast. Tau B which is equal to 9.9 Newton per mm square. After that you have to calculate shear stress at C. Other values are same, only this 250 will be changed. So tau C which is equal to 800 into 10 raised to 3 into 250 into 50 into 153.1 minus 50 by 2, then divide by 516.2 into 10 raised to 6 into 50. So tau c, which is equal to how much? 40.63 Newton per mm square. After that, you have to calculate at D. So tau D, which is equal to 800 into 10 raised to 3 into here 250 into 50 into 153.1 minus 50 by 2, this first bracket close, plus this strip. Okay, so this depth is how much? 153.1 minus 50. So 50 into 101 point, so 103.1, 103.1 into 103.1 divided by 2, then divided by moment of inertia. So moment of inertia 516.2 into 10 raised to 6 into width is 50. So tau d, which is equal to after that you have to calculate at F first and then we will calculate at E. So first you calculate at D, which is equal to how much? चुकते काय तर चेक करा, तुम्ही ब्रॅकेट नीट टाकत नाही. जर तुम्ही ब्रॅकेट व्यवस्थित टाकले तर एक विचार करा, सी ला पण तेवढा स्ट्रेस आहे आणि डी ला पण तेवढा स्ट्रेस कसा येईल, त्याच्यात स्ट्रिप जास्त ऍड झाली आहे ना. डबल ब्रॅकेट टाकत नाही तुम्ही, त्यामुळे तुमचे आन्सर चुकतात. नाहीतर मग एक तर ब्रॅकेट क्लोज करताना चुकतंय तुमचं. किती आता चेक करा, जास्त आलं पाहिजे आन्सर, तेवढंच नाही येणार. हा सांगा किती येते. बघा तुम्हीच टॅली करा आता, मला पण माझ्याकडे पण आन्सर नाही किती. 57.57 57.86 Newton per mm square. After that, we will calculate at F. So at F is shear stress is 800, sorry, force 800 into 10 raised to 3 into. Now we are calculating at F. So below F, we will consider as a area. So here 150 into 50. So 150 by 50 into centroid. Now from this to this distance. So 196.9 196.9 minus 50 by 2. Then divide by 516.2 into 10 raised to 6 into, now here width is 150, which is equal to how much? So tau f, which is equal to tau f, which is equal to door close करा होता है. Tau f, which is equal to कसं पॉसिबल आहे? जर डी ला तुमचा 57.86 आहे तर एफ ला 1 किती येतो एफ ला? हा, मग तेच किती येतंय? ओके, 13 Newton per mm square. Then you have to calculate at E point. Okay, you have to calculate at E. So shear stress at E, which is equal to tau E, which is equal to other parameters are same. Instead of this 150, width will be 50. So 800 into 10 raised to 3 into 150 into 50 into 196.9 minus 50 by 2, then divided by 516.2 into 10 raised to 6 into, instead of this 50, now width at E point is 50. So 50. So tau E, which is equal to 39.96 Newton per mm square. Okay, so this is stress at E point. And after that, you have to draw shear stress distribution diagram. So first I will draw here original figure. So original figure, unsymmetric I section is given. And after that, you have to draw stress distribution diagram. So first we will extend all lines. Then we will draw figure. Suppose this is our neutral axis. Then this line will be likewise, and this is like. Okay. First we will draw baseline here. First we will mark points. This is A, B, C, D, E, F, and G. This distance is 250. This is 50. This is again 250. This is 50, and this one is the 150, and this is also 50. So shear stress at A and shear stress at G is 0. Stress at B is 9.9. Okay, stress at B is 9.9. After that, at C, stress at C is 49.63. So we will write here 49.63. After that, stress at D 57.86. So we will mark here 57.86. After that, stress at E 39.96. at E39. So something here 39.96. After that at F point 13.3. So here suppose we will mark 13.3. So connection is up to this point parabolic, then straight line, then parabolic, then straight line, and here also parabola. So this is the stress distribution diagram. So now take screenshots, then we will stop. Make signature here. Okay, thank you for attending lecture. Today we will stop here. Yes. स्टॉप केले शेअरिंग आता नाही होणार शेअर ठीक आहे नोट्स मधून घ्या परत